Good morning or afternoon. Good day. Okay, we're going to explain to you the More Wavy Motion Lab.
All right, so you should have just finished Wavy Motions, which was the first lab for this. And now you're going to create your own investigation. So it's kind of similar to when we did the electromagnet, where you had to change the number of wraps and then you came up with a new IV to test. This time, though, you're going to choose not only your IV, but you're also going to choose the DV, what you want to measure. Getting serious.
Yes. So our purpose still is to design an experiment to investigate how waves travel in a slinky. So we're staying with the slinky or spring toy.
Okay, so we're going to go kind of walk you through the brainstorming process to make sure that you identify clearly what it is you want to change and clearly what it is you're going to measure, and then some tips to make sure that you are conducting an experiment that is going to give you accurate results.
Okay, remember the variable wheel? We did this together before. Your DV will go here. So the first thing you need to do is brainstorm some DVs. What could you measure in your experiment? You have lots of choices. So you could measure the number of reflections. You can measure amplitude, wavelength, the speed of the wave. The speed actually requires some calculation. So if you choose that, see one of us, we have to help you calculate it. Or you can do the time. Time is different than speed. So you can think about things like that for the DV. I would think the easiest one is number of reflections. What do you think is the easiest for you?
Yeah, I think number of reflections is really easy, but you know we're always game for challenging yourself.
Ooh,
so
it's a challenge class.
you know,
Imagine that. Then on the outside of your variable wheel, in these areas here, that is where you put your ideas for the IV. So if you choose to do the speed in the DV, what about the slinky or the surface you do the wave or the way you start your wave can alter the speed of the wave? So you have lots of things that you could be putting in these outside circles here.
So for instance, when we talk about maybe the surface of the wave you do the wave on, you could go from tile to carpet to maybe a lab countertop to see how that would affect your dependent variable.
Okay, remember you choose one, but if I choose this pretty blue one here, remember what these guys become?
Constant conditions.
That's my favorite part about this. I hate brainstorming those and thinking of those. So you'll get, when you talk about how you're going to make your wave, this is going to be very important. Let's give you a couple of tips here. There's different ways you can make a wave in a slinky. You can do this so complex. First, you could pull some to the side. So if this for Cart to help me, I don't know if you'll be able to see this. You pull it to the side and you let go. But you need to keep that, how much you pull, consistent. The next idea, okay, you can make a longitudinal wave by maybe taking like 20, pushing it back, letting it go on the floor. Gravity is messing this up. Or maybe you can shake. We got to be consistent with how fast and how far you shake it. Finally, the other idea we have is pull and release. Maybe you could pull a few to the side and release those guys. And you'll see a nice, pretty transverse wave. Okay, when you're done with that,
you are going to pick up one of these handy-dandy fill-in-the-blank charts from us. You have seen these before, so same kind of process. The big thing that may be a little bit different is similar to before, you're identifying the control. So you guys have to figure out what your control is going to be. Refer to past tables to try to help you figure this out.
Okay, things to keep in mind. Make sure your wave production method is constant. That is going to produce different variables, unless that is your IV. But most of you will probably choose something else, and history shows us that. But keep that method constant.
Be very gentle with our slinkies, okay? Slinkies, not necessarily the most expensive things, but very, very, very important that you are careful with them because they get tangled very easily, and then they get stretched apart, and then they're all functified, and we don't want to have to buy new slinkies.
Right, and sometimes they're actually hard to find. Right now I see them in the stores, but other years they're impossible, like Target, Walmart, nothing. So just be nice to us. Graphing, we are very nitpicky with our graphing. So you need to make sure you refer to your cheat sheet. It should be in your science notebook in the beginning where we did it together. Make sure your IVDD is in the right spot. Make sure you use equal spacing and all that stuff. We want a perfect graph.
And if you have questions as you go, you need to ask, because you will be taking a lab quiz at the end of this for us to kind of assess where you are on your experimental design techniques.
This lab quiz is the first of the harder lab quizzes. Up till here, it's been like a half sheet. Now it's a full page. Yay! And we expect you to have everything perfect in this lab quiz. So take your time.
Big time now.